In this video, we will work with a frequency table that's already established for us. We already have the class intervals. We have the frequencies. So we'll start with that. We'll construct a relative frequency table, a cumulative frequency table, and a relative cumulative frequency table. And then using the relative cumulative frequency table, we'll construct an ogive that we can do in Excel with a little bit of tweaking. And then we'll also need to be able to interpret these. So this will go along with the lecture notes that you have on frequency distribution. And the only thing new really is using Excel to construct an ogive. Another thing that's in the same notes will be taking a frequency contingency table, finishing it off and being able to interpret it, and then also using that information to construct a relative frequency contingency table. And this will be important when we get into probability later on in the course. So let's start with the frequency table, and you can see here that we have established 6 categories or 6 classes of ages, and we have frequencies. From city A, we have the frequency that there's 3,160 individuals that are between 0 and 15 years of age, or less than 15 years of age. There are 3,676 that are between 60 and less than 75 years old. And then there's 3,136 that are 75 years or older. Now these all add up to 20,300. So I just summed those to get that. And that'll be important. That'll help us in doing some of these calculations here. Now that could be the entire population of the city, 20,300. It could be a very large sample of, say, New York City or Los Angeles or whatever. But for now, let's just say it's the population. We happen to have information, a census on city A. And for relative frequency, we would just take each frequency and divide by the total. And I'm going to freeze that. And I've already got it formatted as a percent. It doesn't have to be a percent. You can leave it as a proportion unless I say otherwise on an exam or assignment or something. But it generally doesn't matter that much. It's just kind of up to the researcher, the presenter. Cumulative frequency, you're just going to keep adding as you move from category to category. You're just going to keep adding values, and so obviously at the very last category you're going to get the 20,300. So the first category is just going to be the original number, the frequency number, and then you're going to take that plus the next number, and then you can just copy that down. And again, the last value then is 20,300. Obviously 20,300 individuals are more than 75 years or more years of age or less. Kind of awkward how to say that, but that's essentially what we're saying. So then the relative cumulative frequency, you have a couple options here. You could do like we just did here. You could start with this and then just keep adding these relative frequencies, or you can take the cumulative frequency and divide it by the total. Again, I'll freeze that number and then just copy down. Of course, you know that the last number will be 1 or 100%, right? Okay, so now we have a frequency table, relative frequency table, cumulative frequency, relative cumulative frequency. And you should be able to interpret this. You see that 66.44% of the population in city A is less than 60 years old. You can see that of the 20,300 in the population, 9,740 of those are 45 or less than 45 years of age. Okay, so that's what the cumulative is doing. And then of course the relative frequency is saying that of the residents, the City A residents, 17.68% are between the ages of 30 and 45, or less than 45. Now what you should be able to do is, if you're given different values throughout here, so maybe just a few values in this column and maybe a couple values here and one or two over here, you should be able to complete this entire table if you're given the right amount of data. You obviously know if you have the total here, 20,300 in either one of these spots here, you know that you could take, if you have 0.1768 or 17.68, you know that you can take 0.1768 times the 20,300 to get the 3589. So things like that. You know that 0.4798 times the 20,300 will give you the 9740. So just understand the relationship between those different frequency tables. And so next what we'll do is we'll take this relative cumulative frequency and we'll try to construct an ogive in Excel. And what I'd like to do is basically let's take and copy this over here. And for an ogive, we really need to have another column here, the lowest value right here, and of course in our case that's 0. And then we could leave this, we could bring this down, I guess, but I'm going to bring it over here as well and make that to copy as a value, and again bring this down so I can put a 0 here. And so I'm going to use this then to construct an ogive. So what we'll do is we could just highlight this, go to Insert, Line, and I'm going to select the one with markers. And we have somewhat of an ogive. There's a couple of issues, kind of like the histogram in the other video. First of all, we can get rid of that legend, but you can see that we're not starting at the right place. We really should start here. Plus, we need for these markers to really be at the ticks here, and so we're going to have to make that adjustment. What we could do is right click on the axis, Format Axis, and say on tick marks. Okay, so we have moved these to where they should be and the 0 to where it should be, and so now it looks pretty good, except another issue is that these really should be in between the ticks. So first these need to be on the ticks and these need to be in between. So one other thing that we'll need to do is go to alignment. This isn't perfect, but it does help. Go to alignment and make this custom angle a -1%. You can see then that it moves it. And if you were to do this more, basically what it's going to start doing is, if you have a lot of your interval name is large and it's getting kind of crowded, it just allows you to make it an angle. Sometimes it'll do that automatically as well, but we just want it at 1%, and it moves it over so that it looks a little better. Looks more like an ogive. Here it's just pretty much a straight line, and that's not surprising because of the pretty evenly laid out ages here across the different classes that we've established. A couple other things that we need to do is identify the axis names, the titles, and then also the chart title. You could leave it at relative cumulative frequency. Of City A residents by age, something like that, or you could just call it an ogive of City A residents by age. And then we can, if we click on the chart, go to layout, we can add axis titles, horizontal, just title below the axis. We just type in age. Should have capitalized that. I double clicked, so I got this box we'll get rid of. And then we could add a title for the vertical axis, and we have different options. I'm going to pick vertical title, and here it's just relative frequency. I'm just going to abbreviate, and I didn't do a very good job. And you can make that look different ways. You can see that you had other options. You can make it a vertical title or a horizontal title. We'll just leave it as a rotated title. And so you now have an ogive that's pretty much shows that there's it's pretty evenly distributed, and as you move to the older age, it obviously eventually gets to 100% or a proportion of 1. Now, if you were to say that the first few had a lot higher numbers, let's just put something like that in there. So now let's copy this, paste in here the values. And so now you have an ogive where it jumps up pretty quick. The first below 45 years of age, you're at 80%, almost 80%, and then it kind of flattens out. So obviously ogives can take a lot of different shapes depending on what we have here in the frequency and relative frequency classes, or for each of the classes. So that's an ogive. And now let's move on to the frequency contingency table. We have some given values here of number of employees, their highest degree by company. So we have company X, Y, and Z. We have degrees of high school, bachelor's, and master's. And so you can see that 30 employees from Z, company Z, have the highest degree of a bachelor's. To finish off this frequency contingency table, we want to have sums on the margins. So we'll sum these three values. I can copy that down so we can see how many there are in terms of total number of among the three companies. The total number that have a highest degree of is high school. It's 80, bachelor's 96, master's 72. Do the same thing for how many work for each company. You can sum that column. So there's 58 in company X, 100 in company Y, and 90 in company Z. And then we have actually three different options for the total. We can sum this column here, we can sum this row, or we can sum all these cells here. I'll just do it that way. And we have 248 employees among the three companies. And so we can interpret these in terms of frequency, but we often would like to look at this more as proportion or relative frequency. So that's actually pretty easy to do. We'll just take each number here and divide by the total. So we'll freeze that and start copying and pasting. And we have ourselves a relative frequency contingency table. We could change that to 2% if we wanted, but let's just leave it as the relative frequency. And you can see now you can talk in terms of more generally rather than an absolute number. You can say, well, almost 39% of all employees of the three companies have their highest degree is a bachelor's. 40% of all the employees among the three companies are employed by company Y. So things like that. This relative frequency contingency table will be very important when we get into probability. So obviously the frequency table will be as well, but when we get to probability, this is what we'll be interested in. And so the sooner you understand what's going on here, the better. And these are the margins here, and these are your joint events here. The joint event of being employed by company X and having the highest degree of high school degree. This is a joint event of being employed by company Z and highest degree is a master's. Okay, so just for now, be able to go and interpret from a frequency to a relative frequency, or even back. You can work with either way, as long as you know the right numbers. You can multiply. If you were just given 248, you can multiply 248 by each of these numbers, and you'll get your frequency, obviously. So, and then just know that these add up to what's on the margins here, and same with the frequencies as well. So as long as you know that about the frequency contingency table and the relative frequency contingency table, you'll be in good shape, and we'll combine that with some probability concepts later on in the course.